So have you ever stopped to think about how a super precise robot arm or maybe a high-tech camera, how it knows exactly where it is? I mean, down to the millimeter, even if you unplug it and plug it back in? Well, the answer is this really clever but surprisingly simple piece of tech. And today, we're going to break down exactly how it pulls that off.
Okay, so here's the game plan. First, we'll get a handle on what an absolute encoder even is. Then, we'll peek inside to see how it actually reads a position. After that, we'll see how it gets so ridiculously precise. And finally, we'll uncover this really cool trick called gray code. It's pretty genius. All right, first things first, what in the world is an absolute encoder? And yeah, what's the secret behind its perfect memory?
Okay, so here's the absolute key. Think of it like this. For every single possible position, this sensor has a unique digital name, like a specific address. And what that means is the instant you power it on, it knows exactly where it is. There's no warm-up, no need to calibrate it. You don't have to tell it to go find some home position. It just knows.
And this is really where it shines, especially when you compare it to its cousin, the incremental encoder. See, an incremental one only knows that it moved, not where it is. The analogy here is perfect. The absolute encoder is like having a GPS that tells you your exact coordinates. The incremental one? That's more like having a stopwatch and a compass. You know how far you've gone from your starting point, but you have to remember where you started and do the math yourself.
Okay, so that's the what. But what about the how? How does it actually do this? Let's peel back the layers and look inside. You'll be surprised at how simple the basic idea really is. It really comes down to this elegant little system with four main players. You've got an LED, which is basically a tiny flashlight. Then there's a lens that takes that light and focuses it into a nice, clean beam. That beam shines through this disc that has a special pattern on it. And on the other side, a detector chip is waiting to read whatever light manages to get through.
And here you can see it all coming together. As that disc spins, the pattern of clear spots and dark spots keeps changing. The detector on the other side reads this pattern of light and shadow and turns it into a binary word. It's simple, right? If light gets through, that's a 1. If it's blocked, that's a 0. And because of the pattern, every single angle has its own totally unique binary code.
Okay, so that's the basic principle. Pretty clever. But how do you get the kind of mind-blowing precision you need for, modern robotics or high-tech manufacturing? Well, the answer is actually pretty simple. You just add more lanes to the information highway.
The real secret sauce is just adding more of those concentric tracks, or rings, to the disk. So check this out. On the left, we've got a disk with 4 tracks. That gives us 16 unique positions. But now look at the right. We add just one more track, and boom, we double the resolution to 32 positions. Every single track you add doubles the precision. It grows exponentially.
And just to put that into perspective for you, with only 8 of these rings, the encoder can pinpoint 256 different spots in just one single rotation. That's what gives you that incredibly fine, super accurate control over whatever's moving.
So this all sounds pretty perfect, right? But there's a catch. There's this one hidden, tiny flaw when you use standard binary code that could cause huge, catastrophic errors. And that's where this absolutely brilliant solution called gray code saves the day. So let's think about what happens right on the edge, at the exact boundary between two positions. I mean, in the real world, nothing happens at the exact same instant, right? So what happens if one of the sensors reading a track is just a tiny fraction of a second slower to see a change than the one next to it? And that's where the problem is. Take a look at this. When you go from position 7 to position 8 using standard binary, 4 different bits all have to flip at the exact same time. Now, if even one of them is a little laggy, if they don't all switch in that same microsecond, the machine gets a completely garbage reading for a split second. It's a recipe for a digital disaster.
But the solution is so smart. It's this special pattern called gray code, and it's designed with one simple, beautiful rule. When you move from one position to the very next one, only one single bit is allowed to change. That's it, just one. And with that simple rule, you basically eliminate that whole risk of getting a bad reading.
And really, that's the whole magic trick right there. This one simple but totally ingenious coding pattern is what makes the absolute encoder so rock-solid and trustworthy. It guarantees that the position it's reading is always stable, always accurate. And that's absolutely critical when you're talking about high-stakes situations where one little mistake could be incredibly costly or even dangerous. So, hey, the next time you see one of those incredible robotic arms moving so perfectly, or a camera lens focusing in an instant, you'll know the secret. You'll know how it never, ever loses its place. It's all thanks to a spinning disk, a little beam of light, and the genius of a code that is specifically designed to never get confused. You know, it really makes you think, where else could this idea of knowing an absolute position be a total game changer?